Let's discuss question number 31 from test 3. It is from fluid mechanics. Okay, so a syringe is given. Let me draw the figure. A syringe is given. Okay, and you have a plunger which is pushing the fluid with the help of a force F applied on the plunger, and the velocity of the plunger, let's call v1, is given. So this thing is moving. Okay, and now here you have the water or whatever the injection that goes into the human vein. Okay, so the diameter is given. The diameter is 10 mm. Okay, and the needle, this is basically the needle part where the jet comes out. Okay, and the diameter of the syringe is given, so let's call the diameter of the syringe as 10 mm, whereas and the water density is let me call as rho, which is 1000 kg per meter cube. The velocity I have already written as 10 mm per second. Okay, and the needle diameter, so needle diameter is also given in the figure, and let's denote it by small d, and this is 0.1 mm, roughly 1/10 or 100th actually. In fact, 100th the diameter. The needle will be very small. Okay, and this length is also given. Okay, so let's see what we need to find out. So force F we need to find out. Okay, so if we can find out the pressure on the plunger that comes here, P1, the P1 multiplied with this area will give you the force acting on the plunger. So then we can draw free body diagram with the plunger and then just find out the force. But let the pressure be P here, and the pressure here is atmosphere pressure, because the jet, say assuming your the jet is outside and open to the atmosphere. Okay, so we need to find out P1, so we need to use the Bernoulli's equation. So P1 by rho g plus V1 square by 2g, and now because everything, assuming that everything is at the same level, so the potential energy terms we can neglect it. Okay, so the Z1 and the Z2 terms, the potential head terms, I have taken it as 0 because at the same level. Okay, the height is, there's not much change in the height. So, and also the P2 is taken as P atmosphere, which is we are finding out the, okay, so let's we are finding out the P2. Okay, P2 is P atmosphere, so let's find out that in terms of gauge. So our objective is to find out the gauge pressure here. Okay, so let's find out, let's keep P2 as P atmosphere and find out P1, and let's see what happens. Okay, so now so I know the velocity V1, but V2 I don't know. So how do I find out VT? So apart from this, I need to use the continuity equation. This is my Bernoulli equation. Now because I am using continuity equation, because I need to find out the velocity of the jet that comes out from the needle. So A1 V1 is equal to, so at this, let this be section 2 and this be section 1. So A1 V1 is equal to A2 V2. This comes because the mass flow rates are same, and therefore the volume flow rates also has to be same. So A1 is basically assuming that everything is circular cross section, so pi by 4 d square, diameter of the syringe, into V1 equal to pi by 4 small d square, the diameter of the needle, into V2. So d is given as 10 mm, capital D. Pi by 4 cancels throughout. V1 is given as 10 mm per second, and d is 0.1. D is 0.1 mm whole square into V2. So V2 is basically your 1000 by, so diameter is in mm, and so everything, let's put everything in mm. Okay, so 1000 by 0.1 whole square. So this will be this will basically, this will be your 1000 into 10, 1 by 10 whole square, so it will be okay. So let me just substitute the values. 1000 by 0.1 whole square. Diameter capital D is 10, it is given. V1 is 10 mm per second, so this comes to be 1000 by small d is 0.1. Small d is given as 0.1. Oh, okay. I just small mistake. The small d is given as 1 mm. Okay, so this is 1, this is 1, so it comes out to be 1000 mm per second, or virtually or in fact converting in meters, it is 1 meters per second. Okay, so let's use the Bernoulli equation here. Let's substitute the values. So what we get is P1 by rho g plus V1 square. V1, now V1 is how much? It is given as 10 mm per seconds. Okay, so let me just put P1 by rho g only this side and send it everything else on the left hand side. So P2 by V1 whole square plus your P2 is P atmosphere by rho g. So my objective is to find out P1. If I just multiply with rho g on both sides, so I'll be getting rho by 2 into V2 square minus V1 square plus P atmosphere. Okay, so now rho is given as 1000, V2 we know as 1 meter, and V1 is given as 10 mm per second. So if I substitute all that, so I'll be getting 499.5 plus P atmosphere. Okay, so now if you consider now the plunger, so let's consider the plunger, because we have found out the pressure that comes. So this value is P1. Okay, this value is P1, and the force applied is F, and you will have the atmospheric pressure also here, P atmosphere. So that will be somewhere like this, and P1 will be like this. Okay, so now assuming that pressure is mass, the plunger is massless, so the sigma F, so basically all the forces on the plunger should be M into A, and now because this is almost close to 0, so sum of all the forces should be 0. Okay, so now let me write down the forces. So this is F is basically on this direction, minus in fact the plus P atmosphere into the area of the plunger. So neglecting this small extension where the plunger is applied, where the force is applied, is equal to the P1 into area. Okay, and F is basically P1 minus P atmosphere into A. Okay, and we have got P1 as 499.5 plus P atmosphere. So let's substitute that value into A. So P atmosphere get cancelled. So 499.4, 5 into A is pi by 4 D square, basically the diameter, capital D, the syringe diameter. So I'll be getting 499.5 Newton per meter square into pi by 4. The diameter of the thing is 10 mm, so 0.01 whole square, and this comes to be 0.04 Newton. So the answer is B. Thank you.